Alright, so for today, I'll just do 3 examples, and I'll give you some problems to practice. Alright, remember that tomorrow will be a short quiz, and keep moving here. I hope you guys are having a good week. So today is the 30th, and we'll be finishing up section 6.3, graphing trig functions. Okay, so let's take a look here. So 3 examples. First problem looks like this. Graph 5y is equal to 10 times the cosecant of theta. So let's get y by itself. Divide both sides by 5. Alright, so it looks easy enough. Let's go ahead and do it. Amplitude, period, and phase shift. The amplitude is none. The only graphs with amplitude are sine and cosine. The period, normal period of cosecant is 360, divided by no number in front is still 360, and there is no phase shift. You could either say none or 0 here. Amplitude we say none, but phase shift you could say none or 0. We know cosecant is supposed to look like waves. So I'll actually set this up just like I did for the homework. I'll do one graph to make things go a little bit smoother today. I was just thinking, because we're not meeting in person, you guys can't make fun of me, or at least I won't hear it. So, haha. Alright, let's see here. Copy this. And plop it right over here. I'll do it over here. And I'll do a couple more, just anticipating the homework here. Alright. So let's start with the problem that I gave you. Alright. So let's use this to type it into our calculator. Now the tricky part is we don't have a cosecant button. So this is how we're going to figure this out. Let's figure out what this piece is. And then the way that we're going to go to graph it is we're going to do 2 times that answer. So watch. Ready? So the sine of theta, let's figure this out. So I'm going to type in the sine of theta, or sine mem variable a, at negative 360. My calculator is telling me that this is 0, right? At negative 270, store it, we get 1, 0, negative 1, 0. Now to figure out 2 times cosecant, what we're going to do is we're going to do 2 times 1 over the sine, because this part is just cosecant, right? So if we know that this is sine, 2 times 1 over that would be 2 times cosecant. This would be undefined. 2 times 1 over 1 is 2. 2 times 1 over 0 is undefined. 2 times 1 over negative 1 is negative 2. And then I think this would, of course, be undefined. So what this graph would look like, at negative 360, it's undefined, asymptote. period's 360. And let's see here. At negative 270, it's 1. Negative 180, it's undefined. Or what did I do here? Negative 270, it's 2. All right. And then it's negative 2. So there's your graph. That's how you graph something tricky like that. On your homework, it's going to be cotangent, so you would just do the same thing. You'd find tangent, and then when you go to graph it, you do 1 over that. All right. Second problem I wanted to go over with you is how to graph y is equal to the secant of theta minus 90 degrees. Well, the amplitude would be none. The period, normal period of secant is 360, so 360 over 1 is still 360. And the phase shift here would be 90 degrees to the right. Now when we go to make a chart, I was going to say tart, we don't know what secant is. We don't have a button. So what I'm going to do is I'm going to figure out the cosine of theta minus 90. And then to figure out secant, I'm going to do 1 over the cosine of theta minus 90. 1 over the cosine is secant. So let's try negative 360, negative 270, negative 180, negative 90. Hopefully we'll see a pattern here. So the cosine meant variable a minus 90, and I'm going to store negative 360. I'm getting 0. And the period is 360. Okay, so let's do negative 270 next. Store it. I'm getting 1. Store negative 180. 0. Negative 90. Store it. I'm getting negative 1. Okay, so I start to see a pattern. Now to figure out what the actual graph looks like, we have to do 1 over that. 1 over 0 is undefined. 1 over 1 is 1. 1 over 0 is undefined. 1 over negative 1 is negative 1. 1 over 0 is undefined. Let's plot those points. Negative 360, it's undefined. The period's actually 360. And let's see here. At negative 270, it's 1. Then it goes undefined. Then it's negative 1. Undefined, 1. And you could see it's not a hard thing to graph. We know that this looks like waves. Or I'm sorry, we look like parabolas. So you should be able to handle something like that. The last thing I wanted to go over with you, problem number 3, is something like this. Y is equal to the cosine squared of theta. Now that's totally new. It's kind of like if you have sine of theta plus cosine of theta. What this actually means is just cosine of theta times cosine of theta. That's the notation for just cosine of theta squared. Right? So on our calculator, this is how we're going to figure out what this graph looks like. We have a wave times another wave, probably going to give us a wave. All right, just make sure these are in parentheses. Let's see what we get here. All right, so I'm going to type this in here. Okay, so negative 360, store it. Calculator's telling me that's 1. Negative 270, store it. Calculator's telling me that's 0. Negative 180, store it. Calculator's telling me that's 1. Interesting. Negative 90, store it. Calculator's telling me that's 0. I'm starting to see a pattern here. 0, store it. Starting to see 1. 90, store it. And that's 0. Okay. 1, 0, 1, 0, 1, 0. Okay, so at 0, it's 1, 0, 1, 0, 1. Just to kind of make sure, if we plug in 45 degrees, it's going to be 0.5. Negative 45 degrees, that's 0.5. Yeah, so it looks like we just kind of have a wave. All right, not a big deal. All right, so for homework, this is what I would like you to do. Let me see if I attached it here to the pre-calculus. 30. So this is what I would like you to do. On page 326, I would like you to please do numbers 14 to 24 even and number 30. I'm going to actually attach, I made a little worksheet of these, so you didn't have to look in the book. So I'll attach this. Just complete that worksheet. I'll post the answers with my charts, and it should make perfect sense for you. All right. And remember, tomorrow is going to be a short quiz. Thank you very much. Have a nice day.